Exponent rules, Part 2. In Part 1, we looked at the basics of exponents and covered the product rule, quotient rule, power rule, and raising products and quotients to a power. In this video, we will look at negative exponents, rational exponents, and a couple other special cases. Exponents are used to represent repeated multiplication. For example, x to the 5 or x to the 5th means we're multiplying x by itself 5 times. X to the 5 represents x times x times x times x times x. An exponential expression consists of a base and an exponent. The base is the number, variable, or expression that is on the ground. The exponent is the little number up in the air. For example, in the exponential expression 5 to the 4, 5 is the base and 4 is the exponent. The exponent, 4, tells us to multiply the base, 5, by itself 4 times. 5 to the 4 equals 5 times 5 times 5 times 5. This is the expanded form of 5 to the 4. Exponents follow rules to help us simplify when exponential expressions are combined in various ways. It's important to know how to do this, as it makes a lot of our work simpler. That's why it's called simplifying. When raising any quantity or expression to a negative power, this indicates that we should take the reciprocal or flip whatever is being raised to that power. Then the exponent becomes positive. Some examples. X to the negative 1 equals 1 over x. The quantity ABC to the negative 1 is just going to be 1 over ABC. The quantity 1 over x to the negative 2, we would start by flipping that, or taking the reciprocal to change 1 over x into x over 1, and the exponent becomes positive. So we have x over 1, which is the same thing as x, to the 2. The quotient a over b raised to the negative 3, begin by flipping that. So change a over b to b over a and make the exponent positive. So now we have the quotient b over a to the 3. Then we would apply that exponent to the numerator and the denominator to get b to the 3 over a to the 3. When raising any quantity or expression to a rational or a fraction exponent, this indicates that we have a radical. The denominator of the fraction goes in the crook of the radical sign. The numerator of the fraction is an exponent on the term under the radical sign. So something like b to the 2/3 would become the third root of b squared. Notice that the 3 in the denominator of the exponent went into the crook of the radical, and the 2 that was the numerator of the exponent is an exponent on the b that is under the radical sign. Special exponents, the zero exponent. When raising any quantity or expression to the 0 power, the value is always 1. X to the 0 equals 1. ABC to the 0 equals 1. When raising any quantity or expression to the first power, the value is always just the base. Nothing changes. X to the 1 equals x. The quantity ABC to the 1 equals ABC. For more examples, see the Exponent Rules Examples video, or email me at tutoring@mathdiva.com with questions.